Can everyone hear me all right with the mic sound good? It's good. Cool. All right. My name's Spencer Gietzen. I work with Rhino Security Labs as a pen tester. Today I'm going to talk to you about Pacu, the open source AWS exploitation framework. So I'm a pen tester with focus on the cloud, AWS in particular. I'm the lead developer of Pacu, and so put a lot of work into this recently. And I'm here to talk to you about AWS security and penetration testing, and then how Pacu can solve a lot of problems in that field right now. So in general, getting started with AWS security is pretty simple. You know, there's the CIS benchmarks, a lot of things to get you started, a lot of good resources, white papers, research from different researchers, blog posts, a lot of different things like that. But it's difficult to know when you're doing everything right, and it's difficult to know when you're doing everything right for every one of your environments, all of your resources, and everything like that. So, it's so hard that even some of the best companies are messing it up, and that's been shown time and time again with, S3 bucket leaks and things like that. Uber had a GitHub repo misconfiguration where they leaked some keys out in a commit or something like that, and someone got access to their environment. Tesla, they had an unsecured IT admin console, public-facing. Someone was able to log in there and get some credentials. They started mining cryptocurrency in their account for, I think it was 3 or so days before they had caught that. As well as, Dow Jones, WWE, thousands of other companies with S3 bucket leaks, leaking sensitive data, all kinds of stuff. Not sure if you can read the text in that picture there, but if you've ever looked at a listable S3 bucket, that might look familiar. You can see there's some credit card info, clear text passwords in there, the usual stuff, it seems like. So as bad as S3 bucket leaks are, they're really only the surface of a compromise within AWS, and so it's far more devastating to lose your keys, and if an attacker knows what they're doing with those keys, it can be really, really bad for your company and your environment. So it's a lot of different ways that keys can get lost. This includes GitHub commits like Uber, we just talked about, social engineering and phishing. You could get someone's keys, or most likely someone's username and password for the AWS console this way. Password reuse, this is something I find a lot as a pen tester. I find someone's leaked password online from some database hack, and they're using the same exact password and username across multiple websites. As well as web application vulnerabilities. Through the EC2 metadata service, you can retrieve credentials for a role that's attached to an EC2 instance, basically. So if you can somehow make requests outbound from a server, you could make a request to that and read the response, which includes keys for that server. So that could include server-side request forgery, local file read could get some keys, or obviously RCE, as well as internal threats and rogue employees. I don't think people think about this quite as much because they don't seem as much of a threat, but in general, there's a barrier they don't need to pass. They don't need to compromise credentials. They've already got credentials, and they've already got access to your environment, and you know that. So it's a little bit scarier if that does happen. So penetration testing on AWS, there's a lot of tools out there for configuration scanning, best practices, checking your environment against CIS benchmarks, and things like that. Tools that do this are Prowler, Scout2, CloudSploit, and there's some others. Great tools, and I've worked with some of the developers for those. But as an attacker, there's not very much that's available to us. There are some tools out there like AWS Pwn, Nimbo Stratus, Dumpster Diver, really great tools, and they get used. I know that used a lot, and the problem is that these tools aren't being updated, or a lot of the tools aren't being updated very often. Some of them it's been years, months since the last update, and that doesn't quite match the speed that AWS is changing. And so with the API and everything changing, something more is needed to handle that and handle the new services and new exploits that are coming out. So what we really need in this area is something that can turn complex multi-step attacks into just a single command, make it easy. And then we need to take out the unnecessary and repetitive tasks from the attacker side and developer side who are developing these exploits. Make it easier to expand these and get your work out into the public. And we need it to be future-proof. So we need it to be modular. So an enumeration module can work well with something that's doing some sort of exploitation. Someone who's writing a EC2 exploitation module doesn't need to worry about enumerating anything. Something else should be able to handle that. And it needs to be extensible. So with how fast AWS grows and changes, the tools and modules need to have, it needs to be easy to do that as well so it can keep up. And it needs to be offensive focused. So there already are a lot of Nessus of the cloud tools, but we needed a Metasploit. And so that's kind of how I'll present Pacu here, which is the offensive AWS exploitation tool or framework that I built. It's built in Python 3.5 plus right now. That's what it supports. Covers the whole kill chain, so reconnaissance, logging and monitoring, persistence, data exfiltration, privilege escalation, and general exploitation. It's simple to develop modules for it. We have a built-in template, easy to open that up, see what kind of API we expose, different things, how you can easily get your exploits created and written and added to the Pacu framework. It's extensible, so the built-in API, there's a lot of different functions we offer that take a lot of repetitive code and work out of your hands. And there's session and data management. So a session is basically a project or a company that you'd be working on. If you're working on two companies, Pacu will separate those two, and you don't ever have to worry about data that's being stored getting mixed up or anything like that. And then there's data management through a local SQLite database that holds all the information that's logged over the whole engagement with a certain company or certain session, as well as all the keys that you compromise over time, and you can swap between those anytime you'd like. And then in general, there's error handling, so the program's never going to crash and it's never going to corrupt your database or anything like that. It's currently open source on GitHub with the BSD3 license as well. So I'm going to go through a demo here of Pacu. Start with some compromised AWS keys. I'll go over using the Pacu console, enumerating different settings, data, permissions, escalating privileges to gain some more access, establishing persistence in the account for, obviously so you have persistent access, and then we'll compromise an EC2 instance using a method that could get RCE as the root user for Linux or system for Windows. So you can just run Pacu with Python 3 Pacu. It'll start up. The text is so huge that it might look a little messed up, but whatever. So it found some sessions. I already created a session for GrrCON. Otherwise, it'll ask you to create a new one because there's none in the database. You can choose that. Another problem with the text size, but this is the help output that gets a little screwed up, obviously. But I'll go over a couple of the common commands like ls. That'll give you a list of all the modules that are supported and are in Pacu right now. You can go through and look at the categories and then the names of the different modules. You could also go through and search for something. I want to look at modules that work with EC2 or work on EC2. We get a couple back here, and there's like a one-liner sentence description for each module here. This is just to kind of give you an idea of what each module does. But there's also a help command you can use that gives you a more thorough description and all the different arguments that are supported, what it's trying to do, maybe some warnings about it or something like that. So there's also the set regions command. I'm going to set it to US West 2. And what this command does is sets the session regions to whatever list I just supplied, which is only US West 2. And this ensures that any module you run will only run against modules that you want, or only run against regions that you want to target, and that it will only target regions that are supported by a certain service. So if a module that works on EC2 will pull all the supported EC2 regions, then check your session list, and it'll only target the regions that are in both lists. It's just to make it easier for you. So then there's the whoami command, which pops up some information about the current set of keys. And so we can see here, GrrCON, that's the session name that we've been looking at. Grr is the user that I've already set up previously. And so when you run the whoami command, you'll get the information about the current keys, which are Grr. You can see that here under key alias is Grr. And then I've got my keys set. I haven't done anything else, so that's all that's in there currently. But if we wanted to fill that data up, we could run the confirm permissions module, which will attempt to get a full set of permissions for the current user, so you know what kind of access you have to the environment. You can run that. It'll run, comes back, confirm permissions for Grr, and now I can run whoami again, and it's filled up a lot of different information this time. So we got the username, we got the ARN, the account ID, user ID, groups. There aren't any policies. We can see there's one policy attached, the IAM manage self policy. Then there's the permissions confirmed, which means that the confirm permissions module successfully completed without running into any access denied issues. It's possible that it could get some of your permissions, but you aren't allowed to find out for sure if that's everything. So it'll still enumerate as much as it can, but it'll let you know that it might not be a comprehensive list. So under permissions, we have the allow. These are permissions that are explicitly allowed by an IAM policy or something like that. So you can see I have IAM list on star, so all the list commands on any resource. And then I have the same for IAM get. And then down below that, I have the IAM put user policy permission on a single resource, which is my own user account. This IAM policy variable fills in my user name when I'm running this command, so I can't run this command against other users or anything like that. If there are any conditions for any of these policies or any of these permissions, those will show up as well. So a lot of time I'll encounter permissions that require 2FA or MFA to be set to use them, and that'll let you know if that's the case. Otherwise, it doesn't show up. If you haven't been able to tell already, I can that this is vulnerable to some privilege escalation, and so we'll take a look at that. Obviously I'm going to run the enum EC2 module to try and enumerate instances, but I don't have that permission, so it's going to run. It'll run a dry run boto3 call, the Python library, and it failed, so it didn't enumerate anything. So to fix that, I'm going to have to use the privilege escalation module, which is privescan, and it'll automatically scan your list of permissions and resources and come up with a list of various privilege escalation methods that your account's vulnerable to. And by default, it'll also try to exploit on that. And so ideally, you run this and you've got administrator privileges. We can run it. So some text flew by. We can see confirmed, put user policy. That's one of the privilege escalation methods that are checked for. I had written a blog on 21 different privilege escalation methods, and that's what this checks for and tries to exploit. Put user policy is one of them. It's got the put user policy permission, which we see here. And then it's going to start trying to exploit that. It'll try to use that to put an administrator policy into my user's set of inline policies. It's done so, and it gives me the name. And so now I should have administrator privileges. I can run confirm permissions once more to get the new set of permissions, and then run whoami, and I can see that I've got a new policy under policies with that name, and then under permissions I have star permissions allowed on star resources, which is anything. It's an administrator level account basically. So now, to prove it even further, I can run the enum EC2 module again against instances. And we can see that it found one instance in US West 2. And so now that data is saved into the database. I can run the services command. It'll give me all the AWS services that have data stored in the database. And so we can see EC2. Not going to look into that right now, but we could establish some persistence now that we have administrator access. So we can use the backdoor users keys module, run that. It's going to let me know it's missing IAM user data because we haven't ran that module to enumerate that data. Then it's going to ask if I want to run the enum users roles policies groups module to fetch that data so that this module can complete successfully. Say yes. It's going to run. It found 9 users. Now it's going to prompt me for all the users that it found and ask if I want to add keys to those or not. So I'm going to add them to the sysadmin user. Say yes. Okay, we get a set of keys back. You know, feel free to try and have fun with those. You won't have any fun, but it's worth a shot. So finish that up. Now I can add them to the Pacu database using the set keys command. We know it's the sysadmin user, and then we can copy the keys in there. And so now I'm the sysadmin user within Pacu, and if I run who am I again, it's a whole different set of data because Pacu doesn't know whether these keys belong to the same account or not or anything like that. So they're fully separated. And then I can use the swap keys command to go back to my administrator user while I still have access to him. So I'm going to follow that up with executing some code on an EC2 instance that I have set up to get a reverse shell as the root user. So I'm going to use nc-nlvp, listen on port 5050. This is just my C2 server I've set up separately. Then in Pacu, I can run the add EC2 startup sh script module with the script path to /temp and reverse shell.sh. So what this is going to do is it's going to stop an EC2 instance that it finds, wait for it to be stopped, and then modify the user data that's associated with it, which can only be modified while an instance is off. It's going to give it a directive that will instruct it to every startup run this bash script that I've included in the user data, which is my reverse shell. And so when this is done, every single time that instance restarts, I'll get a new connection to the reverse shell. So we can wait on this. It takes a little bit to stop the instance, just part of AWS, part of shutting down a server. But there are a couple of different ways. So here we go. We see that it updated the user data for the instance, and then it's starting it back up. So now we can wait for that connection here. It might take a little bit. But obviously, in general, you don't want to restart people's servers and cause some problems in an account or something like that. There are other modules that will get root or system RCE without a restart required. So the shell just showed up. Now I'm root in this account. Anything like that doesn't matter. Pretty cool. Get out of that. And to confirm it again, I could run the download EC2 user data module, which will downloads all the user data for the various instances that we had targeted, and we can see I added the cloud boot hook directive, which instructs the instance to run this following script every startup, and we can see my bash reverse shell here. So in the case that you don't want to restart an instance, there's also the sysman EC2 RCE module, which uses AWS Systems Manager to execute code on instances that have the Systems Manager agent installed on them. It requires a little bit more permission than what this one does, but it's something I've encountered quite a few times and gets you a lot of access to the environment without any need of disruption. So that kind of wraps up the demo there. Didn't want to start where I was at. All right, so basically today I talked about the the problem with AWS security and how we can solve that problem with, the problem being the lack of AWS attack tools, which means there's a lack of AWS security awareness because people aren't aware of what possible attacks can happen against their environment when you're just following best practices. You don't know, you might not even know about that kind of RCE in your environment. So any user who has run instances, modify instance attribute, and stop instance permissions can get root code execution on any one of your instances. That's something that would be hard to necessarily figure out unless there's something more awareness around this. So we can fix it with Pacu and more offensive research in AWS. There's definitely a lot going on, but could use more in general, and that's kind of what Pacu is aiming to do, is increase the amount of research that's going into this, finding more attack paths, more viable options as an attacker, as in other areas of pen testing where there's decades of research and stuff like that. So I've included the link to that privilege escalation blog post for anyone that's interested in the 21 methods that the privilege escalation scanner checks for. It's got a demo or guide and information about each one of those methods in there, as well as the Pacu GitHub repo. If you want to get in contact with me, there's my email, spencer.gietzen@rhinosecurity.labs.com, or my Twitter @SpenGeets, and then Rhino's Twitter @rhinosecurity. So want to thank everyone for coming out, and thank you.